Hello there, this is Dr. Deepshikha Patel, Associate Professor, Department of CSE, SRRT, Bhopal. So in this lecture, we will discuss about genetic algorithm. First of all, what is genetic algorithm? A genetic algorithm is a search-based heuristic method that is inspired by Charles Darwin's theory of natural evolution. So when it comes to soft computing, evolutionary computing is one of the important component of soft computing, and genetic algorithm is one implementation of that evolutionary computing. Basically, there were three implementation of evolutionary computing, and genetic algorithm is the one that survived. This algorithm reflects the process of natural selection, where the fittest individual are selected for reproduction in order to produce offspring of the next generation. So the terminology here highlighted are important when we are going to discuss when we are talking about genetic algorithm. So natural selection. So with the process of natural selection, it selects individuals. Here we are saying fittest individual. Fittest individuals are selected for reproduction in order to produce offspring of the next generation. So from a given set of population, two fittest individuals are selected for reproduction of offspring, which in turn added to the next generation. So the logic behind genetic algorithm is something like this. So when we are talking about genetic algorithm, so it is based on search based heuristic method. So we can say we have given a set of solution, and among those set of solution we have to choose the best one, or we can say the optimized solution we are looking for. So this is the population, and population is what it is, the set of individuals, or we can say the set of population set of solutions provided to us, and among these solutions we have to find out the best one. So this is the initial population, and initially we are having A1, A2, A3, A4 individuals. So when it comes to individual is a set of genes, we can say. So every individual is having its own characteristics that is represented by genes. So this is the set or we can say the individual array, where each bit represent its gene. Individual or solution or chromosome are we can use interchangeably. So these are the terminology we are constantly using throughout the lecture. Population is what? Population is the set of solution. Individuals, chromosome, each individual represent a solution, that is chromosome. So through this algorithm we have to find the chromosome optimized solution. Then each individual is having its own characteristics that is represented by bit, and this is known as gene. The process continues with the exchange of genes. So as we have discussed in the previous slide, that we have to select fittest individual. So when we select fittest individual, exchange of gene occurs to produce offspring that will be added to the next generation. So for example, A1 and A2 are those fittest individual we have selected. After selecting the individual, the exchange of gene process is happen, that is known as crossover. Then some other genetic operations are also there, we will discuss in the next slide. So after exchanging the bits, we can find A5. All the bits of A5, if exchanged with A1, having all the 3 bits 0, then the resultant individuals are A5 or offsprings are A5 and A6. A5 with 1 1 1 0 0 0, and when all the zeros are exchanged with these ones, then we find another offspring A6 0 0 0 and 1 1 1. Notion of natural selection. The process of natural selection starts with the selection of fittest individual from a population. They produce offspring which inherit the characteristics of parents and will be added to the next generation. So what exactly the notion of natural selection? Natural selection begins with finding out 2 fittest individual, and when we find, so what exactly the process through which we can find the fittest individual? There is a fitness function through which we can calculate the fitness of each individual, and as per the fitness score we find the fittest individual and select them for reproduction of offspring. We can also say fittest individual parents. So we have to choose parents for reproduction of offspring, and they produce offspring which inherit. So as followed in natural selection, definitely the individual selected will produce an offspring which inherit the characteristic of the parents, and then that offspring will be added to the next generation. If parents have better fitness, their offspring will be better than parents and have a better chances of surviving. So here we follow the law of survival of the fittest. So those individuals who are fit will survive. So if parents have the reason we choose fittest individual is that if the parents have better fitness, their offspring will definitely have a great fitness score and chances of surviving is greater. The process keep on inheriting, and at the end a generation with the fittest individual will be found. So at end we will found a generation where fittest individual will be there. The notion can be applied for a search problem. We consider a set of solution for a problem and select the set of best one out of them. So in genetic algorithm, a set of solution is given, that is our problem space. A set of solution is given, and among those solution we have to find the best solution through applying the genetic algorithm procedure. So there are 5 phases which are considered in genetic algorithm. First of all, we have to initialize population. So the first phase is initial population, second is fitness function, third one is selection, fourth crossover, and last one is mutation. Here I am going to explain all of these one by one. First of all, initial population. The process begins with set of individual which are called population. So as we have already discussed, what is population? Population is a set of solution which we are initially considering. So initially we have a population with individual or we can say solution, and among those solution we have to find the best one when we are going to apply genetic algorithm methods. So each individual in a solution to the problem you want to, each individual is a solution. So each individual is, we are considering that as a solution. An individual is characterized by a set of parameter or variables known as genes. Each individual is implemented with set of parameters are known as genes. Genes are joined into string to form a chromosome. All the genes are combined to form chromosome or solution. So this is the solution, is the set of individuals. Individuals are A1, A2, A3 and A4. and each individual is characterized by some parameters known as genes. So here each bit is representing a gene for any individual, and when we combine all those genes, this represent a solution, or we can say chromosome. So we have to find the best solution among these whose fitness score is greatest. Now fitness function, how to calculate the fitness function of individual, cause until and unless we calculate the fitness function, we cannot find the fittest individual. So first of all, after population has been initialized, next step is to find the fitness of each individual. The fitness function determine how fit an individual is. So with the help of fitness function, or on the basis of value, or we can say fitness score of each individual, we can find the fittest individual or fittest individuals from the population. The probability that an individual with will be selected for reproduction is based on its fitness score. So it's very definite that we are calculating fitness score. So the individual with the highest or higher fitness score will be selected for the reproduction of the offspring. Next is crossover. So as we are done with the selection of individual for reproduction, next step is crossover. What exactly crossover does? Crossover is most significant phase in genetic algorithm, and for each pair of parents to be mated, so the parents or the individuals we have selected, a crossover point is chosen at random within the genes. So in crossover, we are not going to exchange all the bits or all the genes of parents to form an offspring. So what exactly we are doing here? We are selecting a crossover point among the genes. It may be any random point within that range. Through that crossover point, we will exchange all the bits. So have a look at this example. So A1 and A2 are the individual, and a random crossover point is 3. So when crossover point is 3, so here we are going to exchange 3 genes of selected individuals. So first 3 bits of each individual will be exchanged through crossover after selecting the crossover point. Offspring are created by exchanging the genes of parents among themselves until the crossover point is reached. So in that example, our crossover point was 3. So until this point has been reached, the process of exchange will continue. So here all the A1 bits till crossover point and all the A2 bits till crossover point will be exchanged through this crossover process. The new offspring are added to the population. So A5 and A6 are the offspring created by that crossover method. So when these bits are exchanged, the resulting offsprings are A5 and A6. When all the A2 bits are transmitted to A1, we got 1 1 1 0 0 0, and when all the A1 bits are transmitted to A2, we got A6 0 0 0 1 1 1. Next, when we are done with crossover, next is mutation. So basically mutation is we do mutation with a low random probability. So it's not always required to do mutation. If that is required as per the random probability condition, then the mutation will be executed, otherwise we will escape that. So in certain new offspring is formed, some of their genes can be subjected to mutate. So in short, we mutate or we flip some bits of generated offspring in order to maintain the diversity in the new generation. So if exactly we don't want the mirror image of parents, if the new generated offspring will be the mirror image of their parents, so it will be hard to survive for that offspring in the further generations. So mutation is very important. So mutation occur to maintain the diversity within the population and prevent premature convergence. So before mutation, what exactly mutation is doing? Before mutation, the generator offspring A5 was 111000. So when we mutate, or when we flip some bits of or genes of A5, after mutation it will become 111011. So when we calculate the fitness score, so for example, if we are calculating fitness score just by counting number of ones in that chromosome, so the fitness score of A5 will be 1 2 3, and when we mutate the same, the fitness score will be increased by 1. So after mutation, fitness score of A5 is 1 2 3 4. So chances of survival after mutation of A5 are greater. So in order to prevent premature convergence, so convergence is the condition when our algorithm terminate. So in order to prevent premature convergence or premature termination, we perform mutation. Last phase is termination. So the algorithm terminate if the population has converged, or we can say we can define a condition that what can be the maximum fitness score, or when we achieve this fitness score, then algorithm will be terminated. So when we does not produce offspring which are significantly different from the previous generation, if repeatedly we are getting the same offspring, then that is the condition when population converge. Then it is said that the genetic algorithm has provided a set of solution to, and finally at that point we got our solution. So in conclusion, there are some important points to be remembered. The population has a fixed size. So the population we initialize at the initial phases. The first phase is the first step is initialize population. So when we initialize population, the size of population is fixed. So it is very important to maintain the fitness score, cause the individual having lowest fitness score are getting replaced by the new offspring with the better fitness score. So as new generations are formed, individuals with the least fitness die and provide space for new offspring. So all the individuals having a low fitness score have to leave the population space and have to provide a space for new offspring. So fittest of the survival law is working. So who will survive? The individual with the highest fitness score will survive. The sequence of phases is repeated to produce individual in each new generation which are better than the previous generation. So we repeat the process. It's an iterative process until and unless we find the population which is better than the previous generation. We repeat the process, and when we find the almost similar generations, we identify that the population has converged and we terminate the algorithm. So hope you enjoyed watching. Thank you so much.